Hello everyone. In our lesson today, we are going to study lesson 2.2 in your book. You will find it page 39. This lesson is called Scientific Notation with Positive Integers of 10. Then again, it's Scientific Notation with Positive Powers of 10. First of all, we want to understand what the meaning of the word scientific notation. Scientific notation means that you are going to write a very large number in a shortcut method. And we have to write it in a shortcut method. And we will express it in the form a times 10 to the power of n, which means we have to look at a. A is the number. This number should be more than or equal 1 and less than 10, which means I can't accept 0. So I can't write 0 point something. So the number here, it should be 1 and more. Then today we are using only positive integer. Tomorrow is negative integer. Okay, then let me show you how we are going to write the number in a scientific notation. As I said, it will be in a shortcut method. Then I have this table. In this table, we have the information which is talking about. We will continue. Then we said that if we want to write a number in scientific notation, this means that you are going to express the number by a times 10 to the power. In this question, we want to write the number in scientific notation. As I told you, a should be more than or equal 1. So in this question, we want to write the blue way in a scientific notation. So we have the number which is 250,000, and I want to express this number in a scientific notation. If you look at this question at the beginning, maybe might be say that I don't have a decimal point, Ms. Tahar. If you can't see the decimal point, this means that you have the decimal point here, but we didn't write it, which means we will imagine that we have a point at the beginning of the number. Then we are going to move and count how many units to reach only one number before the decimal point. So I can count 1, 2, 3, 4, 5, then stop, which means I'm going to write 2 and then put the point of the decimal, put the decimal point. Then again, decimal point, count how many units? 1, 2, 3, 4, 5. It will be 2.5 times 10 to the power of 5. From where we have 10 to the power of 5. 10 is a standard. Power 5 means how many digits did you move to reach the integer before the decimal point. So as I said from the beginning again, you have a decimal point and you want to move to the left because this power, this is a positive number. I couldn't see any decimal point. So decimal point, it's written, but it's invisible. Then 0 here, this is the decimal point. Count with me. 1, 2, 3, 4, 5, then stop. Put the decimal point, cancel all zeros, so it will be 2.5 times 10 to the power of 5 because we count 5 digits to the right, to the left side. Now, do the same for the whole chart. Could you please try to solve by yourself first? 41,200. Do you see any decimal point here? Yes. we didn't see any decimal point. So you will imagine that we have the decimal point at the beginning, but we didn't write it. So let me start with you to count. I want to write the number in a scientific notation. How it will be in scientific notation? We will start to count. So it will be 1, 2, 3, and then 4. Stop. Look at 4. It's more than 0. Yes, so we will accept it. What about if it was 0? We will not accept. Then 4.12 times 10 to the power of 4. Again, 10 is standard. What is the exponent of 10 when we wrote 41? This is another type of questions. What is the exponent of 10 when we wrote 41,200 in scientific notation? Take care about this question. I'm looking for only the exponent. Back to the question, it was 41,200. When I start to count 1, 2, 3, 4, then stop. So we have 4.12 times 10 to the power of 4. This which I'm looking for. So here the answer, it will be equal 4. How many places to the left do we? 1, 2, 3, 4. So it will be 4. The decimal point with 41,200, it will be equal 4. In this one, to translate between standard notation and scientific notation, we count the number of places the decimal point move. Okay, so writing a number in a scientific notation, so it's written in a standard which it has many zeros, and I want to change it into scientific notation. Then scientific notation, as I told you, we have a specific formula. It should be 0 point something, sorry, it should be a number point something time 10 to the power of according to the question. Let me show you this question and you will try to find it. The distance from Earth to the Sun is about 93 million miles. Write this number in a scientific notation. We will use the same way. I'm going to ask you the same question. You can see any decimal point in this question? No, we can't see any decimal point. So we will imagine that we are going to put a dot in at the beginning of the number. Then let me ask you another question. How many units you have to count to reach or to keep only 1 point before the decimal? Then let's count together. So this is 1, 2, 3, 4, 5, 6, 7. Stop. So I'm going to say the word stop here. Then it will be 9.3 times, how many digits did you count? 7. So the answer, it will be 9.3 times 10 to the power of 7. As I told you, it was a large number, and we want to write it in a shortcut method. It was 93 million, right? And I want to write this one in a shortcut method. So how we are going to write it in a shortcut method? It will be 99.3 times 10 to the power of 7. Now it's your turn. Think and answer. This one, I don't have a decimal point, so I have to count how many digits to move to the left. Then it will be 1, 2, 3. So the answer is going to be 6.4 times 10 to the power of 3. Let's move to the next. Hey, let's count. You can see any decimal point? No, we can't see any decimal point. So we will imagine that it's in the beginning. Then I will start to count. So it will be 5.7. Did you see? It's very large number. I couldn't read it. Okay, so let's use scientific notation to answer the question. Then how you will solve this question? will be, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Do we have 11? Yes, we are going to write it 10 to the power of 11 because it's standard. So it will be 5.7 times 10 to the power of 11. Clear? Let's move to the next question. A light year is the distance the light travels in a year and equivalent all this number kilometers. Write the distance in scientific notation. It's very large number, Miss Sahar. I couldn't read it. It's okay. I'm going to say the same. You can see any decimal point? No, I can't see. So let's answer only. Let's count. So this is 9 zeros, 10, 11, and then 12. Stop. Keep the decimal point, which means it will be what? Huh? It will be what? Right? The answer, it will be 9.461 times 10 to the power of 12. Then, to translate between scientific notation and star notation, move the decimal point to the number of places indicated by the exponent in the power of 10. When the exponent is positive, which is today's lesson, move the decimal point to the right. Add placeholder zeros as need. Tomorrow, inshallah, we are going to talk with negative exponents. Move the decimal point to the left, adding placeholder zeros as needed. This is the second part. It's opposite now. How? This number is written already in a scientific notation. And I want to answer this number in a standard notation. Standard notations, which means I want to remove, I don't want to see 10 to the power of 6. The exponent here is positive, right? Then the exponent, it will help us to know how many digits we need to move to the right. Then let's count together. We will move the decimal point to the right 6 digits. Okay, but what do you notice here? We notice that we have only 1 digit after the decimal point. Only 1, and I'm looking for 6? Yes. So we need how many more zeros? Yes, we need more 5 zeros, which means 3.5. We will move it 1 digit, and the rest we have to add zeros. So the answer, it will be 3,500,000. So this is where we find the number in a standard form and in a scientific notation, and we want to change it into a standard form. So standard form, it has zeros. Scientific notation, shortcut methods, which is a times 10 to the power. In this question, as I said, the decimal points moves 6 places to the right, but one of those places is 5/10 in 3.5. So only 5 placeholder zeros are needed, which means we need only 5 zeros. What is the exponent on 10 when you write 5.3 in scientific notation? Huh? Who will answer this question? If I want to write 5.3 in scientific notation, okay, in this one already satisfy the conditions which we are need. Then I have 5.3 already written in scientific. We have only one number before the decimal point, and we will not move the decimal point anymore. Then it will be 10 to the power of 0. Then take care about this point. What is the exponent on 10 when you write 5.3 in scientific notation? The number 5.3 is already greater than or equal to 1 and less than 10. So look at the number here. It's only 1 digit. It's more than or equal 1, and it's less than 10. It moves 0 places. No, we don't move. We don't need to move 0 places. So it will be 5.3 times 10 to the power of 0. Clear? So we studied today how we can write the number in a scientific notation. And we said scientific notation, it is a method to express a very large number in a shortcut method. And standard notation, we want to expand the number. We want to remove 10 to the power of something to express the number in without 10 to the power. Okay, then this is what our lesson today, and I hope that you enjoyed watching our lesson. So this is just the last part. So this is just to check your information during the session today. We want to change the number into scientific notation. Please think, my dear students, how we are going to write this number. Think 7.034 times 10 to the power of 9. Yes, this one is 10 to the power of 9 and its positive exponents. So we have to move to the right side. How many digits? We have to move to the right side, 9 digits. If you will count the numbers after the decimal point, you will find that 1, 2, 3. How many zero holders we have, zero places we have to put here? Then I'm looking for more 6 zeros. Then it will be like this. Okay, same idea with the second one. It's 10 to the power of 5. How many digits after the decimal point? I have 2, so we need 3 more. The last one, 5 times 10 to the power of 6. Do you find any decimal point here? Write the mass in a standard notation, which means move 10. I don't want to see 10 to the power. Then we have to add how many zeros? We are going to add 6 zeros. Okay, so this was our lesson today, and you have a homework. It's in your book, page 42. Then your homework, it will be in your book 42. Thank you for your watching.